We're going to begin with the lesson objectives. Today is April 19th. I want to start with a reminder that you do need to be practicing your flashcards for benchmark, fractions, decimals, and percent. So take some time each day to do that. These are things that you should have memorized. Today we're going to be focusing on solving one-step inequalities. This is something that we have done before back in December, I believe. And it's very similar to solving equations, except for, look at this first objective here, you must remember that when you multiply or divide by negative numbers, something different happens to the inequality. We're going to show that in just a moment. Otherwise, everything is exactly the same as solving equations. We are going to review how to show the solutions for inequalities on number lines, and review also using inverse operations to solve inequalities, very much like equations. This first video here is very important for you to watch if you have no idea how to do what we are doing. So if you find that you don't understand what's going on, please come back and look at the video underneath the word understand. We have notes as well reminding us what the addition and subtraction properties are. Examples showing how to solve for inequalities, but also to write them on the number line. In this first one, we have x plus 9 is less than or equal to 12. If we subtract 9 from both sides, that's the subtraction property of equality, we end up with x by itself is less than or equal to 3, because 12 minus 9 is 3. So over here, since 3 is a possible solution, where it says equal to over here, that is a solid dot, and then everything less than 3 is shaded in as a possible answer. Now for multiplication and division properties, it's exactly the same thing as equations, except for one major difference when we are doing negatives, and we'll talk about that in just a moment. This does show you an example for positive situations. So we had 3x is greater than 15. If we divide both sides by 3, we end up with x by itself, because 3 over 3 equals 1. And 15 divided by 3 is 5. And so since 5 is not a possible solution, you have an open circle for the number 5, and everything greater than 5 is shaded in. Now in just a moment I'm going to show you what would happen if that happened to be a negative 5 instead of a positive, excuse me, a negative 3 instead of a positive 3 that we divided by. Before we switch to the textbook, I want to remind everybody that extra credit is available if you just do some Imagine Math minutes or Imagine Math Fact minutes each day. You're going to find that you will build up to earning extra credit, and that is the only extra credit that I have available to you, either working Imagine Math or Imagine Math Facts. So in your textbook on page 654, and you can discover this either by using the index or the table of contents, you'll find more examples and rules for following the addition and subtraction properties to solve inequalities. So you can open your textbook and read through that. I wanted to highlight, though, the multiplication and division properties of inequalities because there is a major difference. You'll see here the example that 5 is less than 10. But if you were to multiply both sides by 2, you're going to have 10. 5 times 2 is 10, is less than 10 times 2 is 20. So that follows the rules just fine. So you notice that the symbols are exactly the same all the way through. However, if we were to use a negative number instead, 16 is greater than 12. If you divide 16 by negative 12, you get negative 8. And if you divide 12 by negative 2, you get negative 6. Negative 8 is less than negative 6. So you'll see here the sign switches. So when you divide by a negative number, you're going to end up with the opposite sign. Same thing is true if it was a negative number that you multiply by. If you have a situation in which you are multiplying both sides by a negative 2, 16 is greater than positive 12, but if you multiply negative 2 times 16 and negative 2 times 12, this left side of the inequality is less than the right side, because negative 32 is less than negative 24. It is a much better situation, and there's more value to owing somebody only $24 than to owing somebody $32. Okay, so basically, what you need to understand is when you multiply and divide by numbers that are negative, it's going to flip the sign. It's going to switch from greater than to less than to greater than. But let's do a couple of practice problems together. Gabe went to an amusement park with $40 to spend. His ticket cost $26.50. Write and solve an inequality to show how much he might spend on souvenirs and snacks. Okay, so the first thing is that we need to write an inequality. So we're going to be using less than, greater than, those kind of things. We know for a fact that he had how much money? How much money did he go to the park with? Very good. If you said $40, that is correct. So we're going to go ahead and write 40 down. Now, since he went to the park with $40 and is not intending to use any credit cards, that's the maximum he can spend. He could spend exactly $40 if he wants to, but he can only spend $40 or what? Less than or greater than $40? It's exactly right. He can spend less than $40 or equal to $40, but not greater than $40. How much money has he already spent? Answer that, please. Exactly. He has already spent $26. So he has an unknown amount of money, plus he's already spent $26.50 of the $40 that he has brought to the amusement park. Okay, so how can we figure out what this X is? We need to get rid of the $26.50. So property of equality. Are we going to add, subtract, multiply, or divide to get rid of the $26.50? Answer that, please. Very good. We are going to subtract $26.50 from each side. Go ahead and do that for me, please. If you're not sure how to start, you do need to annex a couple zeros. Write this $26.50 right underneath it. Line up the decimals. Go ahead and complete this, please. All right, so once we finish the subtraction, he has either exactly $13.50 to spend or anything less than $13.50 left to spend. Let's do one more question together. For the next word problem, we've got a table to look at for important information. Dan builds furniture. The table shows his minimum production times. Dan builds children's tables on Tuesday. He works 10 hours. Write and solve an inequality to determine how many children's tables Dan will build that day. Okay, so the important information is not necessarily the day of the week. That's not super important. But the amount of time he worked is important. So how much time did he work on Tuesday? Exactly, he worked for 10 hours. So over here I'm going to write 10 hours. So if he works for 10 hours, it's asking us how many children's tables he built. So we don't need to know about benches or dining tables or china cabinet tables. We do need to know about child's tables. So how many children's tables, how many child-sized tables can he make in 1 hour? That's exactly right. He can make a table in 2 hours. So he's got 10 hours to work. He works either exactly 10 hours or he could work less than 10 hours, one or the other. We do not know how many hours, excuse me. We do not know how many tables he builds, but we do know that he can build one table in 2 hours. So 2 hours times, we don't know how many total tables is going to be less than or equal to 10 total hours. So let's see what we can do here. How are we going to get 2 taken away so that we can be left with only the x. We know what kind of situation this is. What is the inverse of that operation? Should we be adding, subtracting, multiplying, or dividing? Very good. We are going to divide both sides by 2. And when we do that, we're dividing by positive 2. So this will not affect a change in the direction of the inequality. So we are going to divide 2 by 2. That becomes 1. And so we just write 1x down here. It's less than or equal to, and then 10 divided by 2 is what number? Very good. So he can make exactly 5 tables in 10 hours. For some reason, if lunch break or something comes up, he can make less than 5 tables in that 10 hours. However, since it takes 2 hours to make 1 table, there is no way he is going to be making more than 5 tables in 10 hours. But the inequality is he can make 5 or less tables in that time. All right, thank you for practicing with me today. Make sure that you do your very best to get all your work done each day. If you get stuck on anything, please come to Math Help. Please come to the live class. Ask for whichever teacher you need help with to give you support. I am going to ask that one last question, though. What is something that's very important to remember about solving inequalities? Go ahead and answer that for me, please. Thank you for your thoughtful response, and I will hopefully see you in the live classes later today. Come to Math Help anytime you need help. Thank you. Take care.